We started chapter 3, and a couple of vocabulary words. First of all, the explanatory variable is the one that's going to explain, influence, or predict the changes in the response variable. For us, generally speaking, that's called the x. The response variable measures the outcome, and for us, generally speaking, that's the y. Down below, in each problem, we're going to talk about what the explanatory variable is and what the response variable is, if it's possible. And so in number 1, Julie wants to know if she can predict a student's weight from his or her height. So in this particular example, if I want to talk about the explanatory variable, it's the thing that's the input, or in other words, what we would call the x. And so that would be the height. So you enter in the height, and out pops the weight, because that's what you're trying to predict. That means the response variable is going to be the weight. So number 2, they want to see about a relationship between height and weight, but there is no clear explanatory or response, because they didn't say which one they wanted to predict the other. So no clear explanatory or response variable. In number 3, they talk about how does drinking affect the level of alcohol in our blood. And so then they talk about the legal limit is 0.08%. In a study, adult volunteers drank different numbers of cans of beer, and then 30 minutes later, the police officer measured their blood alcohol level. So in this case, the explanatory would be the cans of beer, and then the response variable would be the blood alcohol level. So maybe an important highlight way back in the beginning, whenever you're talking about explanatory, you're talking about x, and whenever you're talking about response, you're talking about y. Kind of important. Okay, so for us, one of the things that's kind of important in statistics is we're going to be using scatter plots, and we'll talk about correlation a lot, or association specifically. And so when you're talking about scatter plots, they're showing the relationships between two quantities, and they're measured on the same individuals. And the values of one variable are going to be on the horizontal or the x-axis, and the other ones are going to be on the vertical or the y-axis. And each individual is going to be a point on the graph. It's very important, number 1, that you know that these are quantitative, not qualitative qualities. So what that means is you have to have a numerical value representing. You can't talk about hair color when you're doing scatter plots. How do you make them? You pick which variable is going to go on each axis. You can make a scatter plot either way. So when they were talking about blood alcohol level and cans of beer, you could have made either one the explanatory if you wanted to, depending on what you wanted to predict. So if I said, Peter's blood alcohol level is 0.1. How many cans of beer did he drink? You could have made the explanatory the blood alcohol level if you wanted to. So you decide which one's the explanatory, which one's the response, and then you make your x and y axis. Number 2, don't forget to label your x and y axis. It's very important on the AP exam. If you're not labeling, they don't know, they don't assume what's going on, they don't give you credit. And number 3, plot each of the individual points. Okay, so on this next slide, and I'll kind of demo this when we do an example, they talk about how you make this scatter plot, and I'm pretty sure that most of you are familiar, but just to kind of recap. First of all, you want to put your data in your 2 lists. I recommend you always use list 1 and list 2 because your calculator defaults to this when you're doing your scatter plot. However, you can put them in any 2 lists you want to as long as you remember which one's the explanatory, which one's the response. After you do that, do second y equals. That takes you into the scatter plots. Hit enter, enter to turn them on. you want to make sure that you use the first type of graph. That's the scatter plot. It's the one that's highlighted in black on the screen. And then notice how in my picture here I have the X list being L1, the Y list being L2, and it doesn't matter which mark you use. Most of the time I actually use the plus sign. You can use the box as the plus or the dots. The dots are hard for me to see as you get older. Your eyes are a little bit weaker, I guess. And then the last thing is when you do zoom 9, what that's doing is it's fitting the window to your statistics in your two lists. So zoom 9 is the one that you always want to use. So we have an example down below here that we're going to try. Why don't you guys type in your lists this sprint time in list 1 and the long jump distance in list 2, and then we're going to talk about how this works out when we do a scatter plot. Okay, so in my calculator in list 1, I put down all of the sprint times, and in list 2, I put down all of my long jump distance in inches. And what I want to do is I want to create a scatter plot. And so since I talked about the sprint times being list 1, that's my explanatory variable. And then my long jump distance would be my response variable, or the y, the output. And what I'm going to do now is I'm going to go second y equals. That takes me to the plots. I hit enter. And then I hit enter again to make sure that they're turned on. I look to see the type is the first graph. I see that my X list is L1, my Y list is L2, and then my mark, I'm using the plus signs. You use whatever you want. And then I go zoom 9. And this will create a scatter plot. Now the thing is, from the scatter plot, it definitely shows you the scatter plot, but I don't even know what the scale is. So that's kind of annoying. I guess what I would do is I go look at my window just to get some idea what's going on. I can see that the x's that they chose by using the calculator's means was 4.66 and 9.94. So if I was actually making a picture, I would probably go from 4 to 10, I guess. They use a scale of 5, I'd go up by ones. They use the y-min at 24.88 up to 207. I guess I would change that a little bit. And then the scale they used there was 1. I don't really understand why they did that. So now I'm going to go back to my notes here. And when I draw my picture, it's going to look a little bit different than what they chose for the window, because that was based on the calculator's demonstration. So as I graph, remember that when you make a scatter plot, you need to label the axes. So this is the sprint time down here in seconds. And off to the side here, there is the long jump distance, and that's in inches. And I noticed that my sprint times go from, I don't know, 5.1 up to 9. So I guess I would show a break in the graph, showing that you're not starting at 0, bless you. And then I would go with maybe 5, and then 6, 7, 8, and 9. And then if I'm looking at my long jump distance, knowing that I go from 65, it looks like, to how much?
48.
Oh, sorry, yeah, 48, all the way up to 184. Maybe I'll just go up by 20s, I don't know. So 20, 40, 60, 80, 100, 120, 140, 160, 180.
Should you go up to 10 on the x-axis and do the 25?
So it's been brought to my attention that maybe we should go up to 10 there. So 100, 120, 40, 60, 80, 200. And then I can plot these different points. So as I'm plotting these different points, at 5.4, I'm 171. So that's maybe somewhere up in here. And then at 5.1, I'm at 184. And then at 9.5, I'm at 48. And my graph may look a little bit off because I'm trying to judge this while looking vertically here. 8.1, I'm at 151. At 7, I'm at 90. 7.2, I'm at 65. 6.8, I'm at 94. 6.7, 78. 8, I'm at 71. 5.7, I'm at 130. 5.8, I'm at 173. 6.3, 143. And then at 6, I'm at 141. Did I miss any? When you're interpreting these scatter plots, you want to look for the overall pattern in your graph.